Okay, this is Nobles here. I rigged up some contraption so we can learn a little bit more about the VEX Cortex and such. So let's give this thing a try. You're just gonna have to deal with that. Try not to get seasick. There we go. Okay, so let's quickly go over this. I don't want to spend a ton of time on this. It's pretty basic stuff. What we're gonna do is gonna be a little prequel to a video on how to actually use the programming software and do the stuff, but I want to give you an overview of what I'm doing first. I got my Cortex here. I got a simulated drivetrain setup, right? This is the one side of my drivetrain. So this is both powering the left side of my drive, we'll say. Both of these motors need to run on this joystick, number 3 for the left side, together, synchronously. So we need to synchronize these two motors together. Okay? Because they're part of one high current element of the drivetrain, I have these two wired to both ports 2 and 6. This is important because ports 5 through 1 are on one circuit breaker. Ports 6 through 10 are on another circuit breaker. So you want to try to break up big subsystems. Like if you got an arm that you know is going to draw a lot of power, put it on two different sides of that, right? Maybe one on 5, one on 9. Okay? So we got to synchronize those. That's task 1 on our programming thing. Get the robot driving around. Task 2, making sure the robot doesn't break itself. Here we have a cam set up to trigger 2 limit switches. When the motor is driving in one direction, as soon as it hits this limit switch, it should automatically turn off and limit you from driving it further and further and further and bending stuff. It should only let you drive in the other direction, until of course you crash into this limit switch, in which case it should stop rotation in that direction so you can't go and crunchitize everything. Okay? One important thing to do before you get any of this done, okay? You got to be mindful that motor orientation is going to play a role. In this case, I have 3-wire motors. If you have 2-wire motors, you got to make sure that those 2 wires, positive and negative, aren't flipped around, because I guarantee you in a lot of cases they will be or they'll need to be. And what you don't want to do is turn on your drivetrain with 2 motors fighting each other, and you can blow up gears, you can hurt stuff, you can hurt your motors, you can burn up electronics as well. So got to be mindful of that. The last thing on our to-do list, we're going to make a program that will allow this to trigger our autonomous mode. The teleoperated and autonomous mode programs are going to exist in the same file, but they're kind of separate elements of it. And we'll get more into autonomous mode in a different video. This video is primarily tasked with making our teleop setup work. Okay? Before we get started with anything, make sure you take a look at your controller and plan out what function will be where. In your engineering notebook, you should record channel 3 for the joystick and what ports these motors are running into. Would not also be a bad idea to take some tape and label these. You know, I don't care if you label it motor C or motor B or whatever. You know, label these motors and make sure you know what ports they correlate to. So drivetrain, 1, drivetrain 2 are in ports 5 and 6. Something so that you know this motor in relative to its location in the robot as well as what port it plugs into. Doesn't help just to know the port because you don't know what motor that actually is. So give these things a name. I don't care what you name them as long as it's school appropriate. Okay? So anyways, that's that for that video. I hope I was fast enough for you. I hope you didn't get too bored. And I hope this vertical camera setup Majabra thing works pretty well.